Good evening, friends. Welcome to Eastern Academy. And we are today going to discuss about digital electronics as a part of embedded system programming. This is session 5, and we're going to discuss about application of sequential logic. So, the last few classes we discussed about what is digital electronics, what are the fundamentals, and what is combinational logic, and what is sequential logic. Let us revise all of them before we get into the sequential logic. Understand? So this is slightly a nice one, but as I mentioned to you that we should be very clear about this logic. They are the fundamentals. I tell you once again, whole digital electronics start with a switch, remember, and you control a switch through voltage. That's it. So a switch, and from the switch we derived three logics, gates, and or not. It can be any number of inputs, not only two, it can be any number. Normally we draw two, but it can be any number. From this, we derived three logics: combinational logic, sequential logic, and here is the application. And this is not a very important one, but this is important. Same way, this is important. And we're going to discuss about today application of sequential logic. What are the applications? So let us first of all make sure that we understand things very clearly. That is what, see, you may learn a lot. You will learn a lot, but if you start remembering everything, you're gone. So you should know what to remember. So in our case, we have to remember these functions: AND gate, OR gate, NOT gate, like addition, subtraction, multiplication. Remember only this. This is the basics. And if one input is 0, output is 0. If one input is 1, output is 1. 0 means 1, 1 means 0. That's all. It's very simple to remember. Don't get confused. Now, in the combinational logic, if I give any combination of the name for the box 110, 11110, see 8. Understand, I have 8 inputs. How do I solve it? Quite simple. I put a AND gate of 8 inputs. Then I have 8 inputs: 4, 5, 6, 7, 8. Then I have 8 inputs. You want 1, 1, 0, 1, 1, 1, 1, 0. Am I right? Now 1 means direct. 1 means direct. 0 means all 1s to connect direct, all 0s to connect inverter. That's it. If you know this, you know combination logic. This is what very important. You'll be very surprised. In later, if I write anytime, there's a block with 1101. You should be able to draw what is inside the circuit. Okay, this is a quite easy one, and don't try to remember too many things. Then we have seen yesterday, the application is called adder, subtractor, and mux, demux, encoder, decoder. Why I mentioned this is this we have seen in the college, but don't worry about that. They are not very important for you today. Now, yesterday we have seen another thing. Important thing was a sequential logic. It is quite simple, not as complicated as a combination logic. This is, you have an input, you have an output. There's a switch that is controlled by your control input. When control input is 0, switch is off. When control input is 1, the switch is on. When switch is on, that is, if I say that I call this is a D, this is Q, this is C. If C is 1, the switch is on. So DQ. D is 0 means Q is 0. D is 1 means Q is 1. So because switch is on. Now, when C is 0, the switch is off. But this guy is having one speciality. When C is 0, D could be anything that does not affect the Q. But Q is the previous state, which we have seen that how it remembers. We did the feedback. So even though we have discussed, you can forget all these things. Because if you start remembering everything, then you are gone. You remember only very limited. So remember the combinational logic, 4 inputs, 1 output. Then remember the sequential logic, D, Q, and C. These two are remembering. Now we discuss about the another combinational logic application of sequential logic. There are three major applications. One, 8-bit register or latch. 8-bit register or latch. That's a major application. This is what you have to know, very important for our entire embedded system. This is a very critical one. Okay. The second one is shift register. This is, you know, just know that how it is doing it. That is enough. And third one is counter. Okay. So the application of the D flip-flop, that is sequential logic, is 3. But whether you remember this or not, I'm not very interested. But this is very important. Please understand this. What is this? Let us discuss about the 8-bit latch. That means that I'm using 8 of this D flip-flop. How much? 8. I could draw only 6. Sorry. I've drawn 8. And 8, all the 8 are having input and output. The input outputs are not same for all of them. There are separate input, separate output. Please understand. If you don't understand this, let me know, please. I have 8 D flip-flop. Understand? 8. Okay. Is it clear? And all of them are having a control input, C. I take all the control inputs and connect them. See that? It's called C. This, since we have 8, we call this as a D0, D1, D2, D3, D4, D5, D6. See, these are only one time you have to remember. Then lot more, you don't have to do that. You can forget it. So, now you understand this. Now I put a box here. I put a box here. When I put a box, this is called 8-bit latch. Don't get confused with RS latch. This is a 8-bit latch. or this is called 8-bit register. You can call anything as them. Depends on the application. They call them different name. Or you may call 8-bit D flip-flop. But as I mentioned to you yesterday, the classes, this is boring. Drawing this much is boring. So what people did was, they have drawn this in a very simple way. D, Q, C. And they put 8 here. There's only one C. C is only one. That is written only one, no slash. But whereas D and Q are this. That means forget about this. Now, you know that what these two are same. If you have any doubt, you can ask me now, before we proceed further. This is called 8-bit, all are same name. You may call whatever name. See, why I'm explaining all these things is because you have to know that the whole digital world works on only about 10 components. 10 components, that's all. With the 10, how we are going to make so much of massive impact to the society, to the products, that has to be understood. If you don't understand that, for you, everything will be great. Oh, something great is happening on artificial intelligence, something happening on machine learning, something is happening on embedded Linux, all embedded. Oh, you'll find a difference between Arduino board and ARM board, but everything is same. Understand? There are only 10, about 10 components. What are the 10 components? Which I repeatedly told you that, and or not. Only 3 logic. Like we have a addition, subtraction, multiplication. Only the 3 logics. Yeah, this is not called clock. This is called control. We don't call this as a clock signal. We call this as the C is called control. Please understand. The C is not called clock. And that's why we call 8-bit latch. All the 8 are going out. No, we don't use them. That's why I've said these are all your olden day syllabus. Old school technology is called JK flip-flop, DT flip-flop. All those things are master slave. These are all old school. We are not here to teach you everything. I told you this is not a college. Here it's an industry. What exactly industry uses, I will tell you. This may be there in your syllabus. Okay. So I'm not teaching the engineering syllabus here. I'm teaching exactly what the industry wants. I want you to remember very little and do big. And see here, somebody has asked that why we are giving a common clock signal, then how it is called a latch. Okay. Now this is called 8-bit latch. That means that if I have a block with 4 inputs and 4 outputs and a control signal, we call this as a 4-bit latch. That means that if I give here 1001, if a C is 1, the output become 1001, please. All the 4 will go out directly. 4 wires. The input 4 wires, D0 to D3. Output is Q0 to Q3. They go individually. Please, I'm requesting you to thoroughly understand that this is what the one which is going to be controlled by you by using a software. When you write a program, CHAR star X, X is equal to, let's say, 0x51. Sorry, 1000. Star X is equal to 0x51. Let me draw that. Let me give you the concept now. Since you have understood both combinational and sequential, I will try to explain this. What is the meaning here? This has to be understood by you very thoroughly. If you don't understand, please let me know. See, I have 2 logics. See here, I have a logic called sequential logic, which has 8 input, 8 output. Understood? 8 input, 8 output. And there is a control signal called C. Am I right? This do you agree? You agree this? I have a 8. That means that internally I have 8 D flip-flop, 8 copy, 0 to 7. Since in the digital, we call from 0 to 7. Okay. Now, I have another logic. This is called combinational logic, which gets a name 1257. Let us assume 1257. This guy is having a name. 1257 means it's a 16-bit. 1 means 0001. 2 means 0010. 5 means 0101. 7 means 000111. This is hexadecimal. Because we don't like to write the so big binary. That's the reason we have written 1257. That means that if the 16 wires, if this input comes, this become 1. What I do here is I connect here. Now, the beauty is this 8 is coming here. Understand? Now let us draw a. Understand now. This 8, if I give 15, that is 0001, 0101. If I make this as a 1, then this will become 15. Now don't get confused. See here. I've drawn here 8, but let me expand it to you 8. Expand to you like this. 1, 2, 3, 4, 5, 6, 7, 8. D0, sorry, Q0 to Q7. We write 15 here. This is LSB. This is MSB. So this 0 goes here. 0 volt, 0 volt, 0 volt, 5 volt, 0 volt, 5 volt, 0 volt, 5 volt. Do you understand that? Now, who is going to give this here? 1257 and 15. That is what your program. CHAR star X. X is equal to 0x1257. Star X is equal to 0x15. Do you understand these 3 lines? These 3 lines are one which is giving. And now let me give you one more clue. What is happening? I write here this program. CHAR star X. X is equal to 0x1257. Star X is equal to 0x15. Am I right? Now I give this to the who? Yeah? Microprocessor. That we will discuss when we discuss about microprocessor. I'll discuss, but of course you will attend the next session on microprocessor. That time you will understand more. Otherwise, go and watch the recorded versions of microprocessor class. You will get an idea. Now your software here. Understand now. Your software, this software, when you give it to microprocessor, he will give here 1257 and 15. Since this combinational logic, if you get 1257, we make this as a 1. That comes here. This goes here. If you connect a bulb here, that will become on. So now you understand the purpose of this 8-bit latch and the combinational logic, how it is working on your system. This is what you are going to do the entire embedded system programming. This is what all about embedded system programming. I have just given you the application of what is combinational logic, application of sequential logic. Please understand. Do you understand this or not? I'll give about 2 minutes. Please try to tell me whether you have hear anything, don't understand. This board, let me know what you don't understand. Yeah, that's why 15 is data here. Yeah. This is address. This is data. That's what you are writing here. Or you can call pointer and variable, whatever it is. That's the reason I've written a program here. Now you understand what is the importance of C program, what is the importance of pointers. In the pointers, you are going to control the address and data, and that is going to come out. But you'll be very surprised. If you understand this thoroughly, maybe I don't mind. You watch the video once again, you ask me any doubt, but you need to thoroughly understand this. If you don't understand any of this here, that is, if you don't understand the program, ask me. If you don't understand how the microprocessor gives, ask me. If you don't understand combination logic, fine. This is what all about embedded system programming. Please, you'll be very surprised. No, I've drawn this to make you to understand what is the use of 8-bit latch. Somebody asked me what is the use of 8-bit latch. I've given it the 8-bit latch. Do you agree with this? Fine. So one of the application of sequential logic is 8-bit latch. Sometimes this is also called 8-bit. Both are same. Please understand. Don't get confused between latch and the register. They call sometimes CE as a latch enabled signal. They call this as a latch enable. Is it clear? Now let us get into the other application one by one. But if you have a doubt here, please. No, binary input is also 5 volt and 0 volt only. Everything is 0 volt and 5 volt. When you put a wire, when I put a wire, physical, see, when you do physical, everything is voltage. There is no number called physical. If somebody has asked, for SL, we are giving binary input. Then how it is behaving? No, the output is also same, 15 only. But I have written like this. The reason is when you are handling a program, the number is number. But when you are getting connected to the electrical device, that time number become voltage. But actually everything is voltage. Please understand. The whole board is handling only voltage, on or off. On means 5 volt, off means 0 volt. That's it. So when I write here 1257, this is 0 volt, this is 5 volt. Please understand, when I put a wire, if I write 1, that is not 1, that is 5 volt. We just for our EC to represent, we write 1. So there is no 1 and 0. Please understand, in digital world, there is nothing called 1 and 0. All of them are only 0 volt and 5 volt. Since mathematical representation, we make 1 and 0. But in the physical world, everything is only voltage. If there is no voltage, no current. Nothing is passing. Please. This is a good question because nobody asked, but nobody understands. Why? How come I've written for 1.5 here, but how come I written 0 volt and 5 volt? But actually, this is also same. Okay, is it clear? No, I've written 0.5. I put 0x. If I write 15, if I write here 15, then this becomes F. Then become 0, 1, 1, 1, 1. So the compiler will convert it. If you write 15, then it becomes F. Then this becomes F. Then this becomes 0 volt, 0 volt. All the wires become 5 volt. So 4 wires become 5 volt, 4 becomes 0 volt. That is 0, 0, 0, 1, 1, 1. If you give decimal, that compiler will convert it to binary like this. If you give hexadecimal, he will convert it to other way. That's the way. No. This is not, there's no analog here at all. Here, everything is digital. There's no analog here at all. Please don't get confused. I don't discuss analog at all. This is only digital. Converting one number system to other number system, that's all. We don't discuss about analog, digital or anything. Because somebody asked digital to analog converter. So now, let us go to the next thing. Let's discuss about the next one. That is, what is the correct? I don't know what is happening. Let me correct it tomorrow. Somebody has asked the question, it should be public. Now it is doing only direct message to me. I have to read it. See, somebody has written it. All the port and data addresses inside the microcontrollers are made using combination. Exactly. Your microprocessor or microcontroller all are built using only three logics: combination logic, sequential logic, and tri-state logic. Only three, nothing more than that. There is no other logic involved in your microprocessor, only three. We have discussed one. We have discussed two. We will discuss today, next session, third one. Then you will thoroughly understand how we built the whole. See, it doesn't matter, man. It could be 2-story building or it could be 10-story building. Everything is built using a brick. Maybe less here, maybe 10,000 brick. This could be 1 lakh bricks. That's it. That's a simple. Whether I build a house, everywhere it's only a bricks, nothing more than that. So let us have a thing like this. See here. I give here this output connected here. See here. This is called clock. Sorry, C, not clock, C, control. C and D. If you give 1 here, if you make C as a 1, then this one will go here. But the problem is, since the C is 1, this one also will go there, which people don't want. So for that reason, we use here, I've already explained about the sequential call, edge triggered, positive edge. Now what happened? For example, this is previously 0 and this is 1. And this is previously 1, assuming. This is out, this is in. Now, when you make C as a 1, 0 to 1, when there's a edge, this 1 will go here. By the time the same clock 0 will go here. So this will get changed into 0 and this will get changed into 1. This will be 1. Now you understand how the data is getting shifted to the next one whenever there's a edge comes. But later nothing will happen. But when I give next time edge, next edge, this one will go here. This one will go here. All of them output is 1 now. So it takes how many clocks? The first edge, it goes here. Second edge, it goes here. That means it takes 2 clocks. If I connect here, one more. I have 4. Now, what happened? Forget about this. I give 1 here. I connect all the C. I'm telling you, I've not come here to teach you the college syllabus. So, if you don't understand this, forget it. No problem. But what I'm trying to tell you now is, If I give all of them are edge triggered. If I give a clock here, first signal control, when there's a rising edge, C, this one goes here. Now, when I make the second edge, this one goes here. When I make a third edge, this one goes here. When I make the fourth edge, this goes here. So it takes 1, 2, 3, 4. The next edge will go there. This is called serial in, serial out. This is one of the major application of your sequential logic. That is what is in what I'm using is a D flip-flop. Please understand. Everywhere I'm using a D flip-flop. Okay, this is called serial in, serial out shift register. Now, think of it. I have a same thing here. Understand now. I have same. But what I do here is I take the input here. Understand now. I take the inputs here. If I have a D0, D0, D1, D2, D3. This is Q0, Q1. See, this is like when you're learning in the school, initially you add 1 digit, then we add 2 digit, then we learn to add 3 digit, then we try to add 4 digits. This 1 hour alone is not sufficient for you. Here I'm giving you the idea. Go and watch the video repeatedly and try to understand. That's the thing. Because I can take this class alone for your entire 3 months. Digital alone, but no use, because we are not going to work on the digital world. Our job is to move it to the embedded system programming. I am giving you the idea that how I am using the sequential logic. Okay. Now, what is happening is, if I give a C here, okay, if I give a C here, the input will come to the output. This is called parallel load. This is called parallel in. I'm doing parallelly in, but this is not connected to this because I cannot connect 2 outputs. You know what they have done here is, this is a beauty here. Here, there's a block. Both comes here. What? Both comes here. This also comes here. The input also comes here. Here also there's a block. Here also there's a block. From input comes here, this comes here. There'll be a block. This is nothing but a combination logic. I have 2 inputs, I have 1 output. I have 2 inputs, I have 1 output. I have 2 inputs, I have 1 output. I have a control input. I have a control input. The control input will decide, whether I am going to do the parallel input or sequential. How is that? I'll explain to you now. How is that? Very simple. See here. I have a block. I have 2 inputs called data in. I call this as X. This is X3, X2, X1, X0. So this is X2. I give X2. And what is coming here is a Q3. Understand now? Q3 is coming and X2 is coming. but only one has to go output. I have only one thing is output, that is D2. Am I right? I have one input called, that is called shift / parallel load. That means that if it is 0, it will shift. If it is 1, it will load parallel. Then what is inside the logic? See here, once again I use AND gates. Once again I use the AND gates. Understand one thing here, please. If you don't understand, I'm not worried. I don't want you, I'm not drawing here for you to understand. I am trying to tell you information that everything is combinational, sequential, and tri-state logic. That's what I want to show you. I don't want you to go in depth. The one biggest problem with you people is going in depth. When you go in depth, you don't achieve the top ones. Don't go in depth everything. Just understand. Now I have here X2. I have here Q3. I have another input called SP, shift or parallel. Now I take the SP. See here how I've drawn this. Very simple. X2 and M2. I've expanded this now. Now, when SP is 0, what happened? This became 1. This became 0. So this output is 0. Now X2 goes here. So output become S2. When SP is 0, D2 become X2. This is called parallel load. Now, when I do SP is equal to 1, when SP is 1, this becomes 0, but this becomes 1. So the Q3 goes here. Now Q3, D2 become Q3. That means that I can make this guy to function like a loading. You know one thing? What is the equivalent software? See, CHA star X. Sorry, X. X is equal to 0x12. Okay. Now you say Y is equal to X right shift by 1. This is the first operation. You are loading. This is called load. This is called shift. This operation. So I'm giving you an equivalent of what is there in your C program. You use the right shift and left shift. Okay, both of them are doing that. So these are all there inside your microprocessor. Okay, so don't try to get into the too much of thing. Your shift register. I'm not here to discuss about digital electronics. I'm giving you a simple idea that your shift register is nothing but if it's a 8-bit shift register. 8-bit shift register, then I have a 8 flip-flops and I have a 8 inputs and I have a 8 outputs and I connect the shift. So if I write a program, char star X, sorry, X is equal to 0x10, Y is equal to X right shift by 2 times. Then there will be a two pulse will come into the control input. It will shift into 2. So the data will be shifted twice. You know that these are all the very famous one used. You will understand this when you do the UART, SPI, I2C, CAN and dot. These are all built using this. This is called parallel to serial converter. Understand? This is what the application. So don't get into the deep. So the second application is shifting. The third application is very simple. Let us say The same here. Okay, the same logic here. I'll try to understand that. Very simple way. I put only three of them. Please understand, I put only three logics. I have a Q2. I have Q1. I have Q0. I have D2, D1. Understand now. This is a D flip-flop which has three inputs and three outputs. Now, I have a combination logic here. Understand, I have a combination logic. Now, this takes three inputs. What are the inputs? Q0, Q1, Q2. Please understand. So this is combination logic. This is sequential logic. I have designed the combination logic in such a way that how many inputs? Three inputs. Please understand this. We have a three inputs. What are the inputs? Q0, Q1, Q2. What are the outputs? D0, D1, D2. Is it clear? Now I'm going to draw like this. If the input is 0, 0, 0, the output becomes 0, 0, 1. The input is 0, 0, 1. The output is 0, 1, 0. 0, 0, 0, 1, 0 means it becomes 0, 1, 1. 0, 1, 1 means 1, 0, 0. Understand? 0, 0 means 0. 0 means 1. Now we assume initially all of them are 0. We assume. Now this three zeros will go here. Okay. This becomes, since the input is 0, 0, 0, output is 0, 0, 1. But that will not come out. The output is still 0, 0, 0. Now see here, I have a C here, input. Now, when the C is rising edge, during the rising edge, this 0 will go here, 0. This 0 will go here. This 1 will go here. See here? Now, when there's a rising edge comes, the output moved from 0, 0, 0 to 0, 0, 1. Now we see here. Now what happened? This 3 will go here. 0, 0, 1 will go here. Now everything fine. What happened? When there's a next edge comes, clock edge. When there's an input is 0, 0, 1, output is 0, 1, 0. So this becomes 0, 1, 0. But this will not come out here because the edge does not come. When there's an edge comes, this becomes 0, this becomes 1, this becomes 0. So 0, 0, 1 becomes 0, 1, 0 becomes 0, 1, 0. Now this will go here. And 0, 1, 0 means output is 0, 1, 1. Now it's a trick. This will not come out unless there's a next edge. When there's a next edge comes, this becomes 0, 0, 1. So 0, 1, 0 becomes 0, 1, 1. See here, 1, 2, 3. So this is called 3-bit counter. This is called 3-bit counter. Correct. Q0, Q1, same for both. Correct. You're perfectly right. I've taken the wire from here. That's why the name. We have taken a wire from here. Let me connect it. We have taken a wire from here and connected here. We have taken a wire from here and connected. We have taken a wire from here and connected. You are right. All are same. So this is actually called counter. If you want 4, I'll have add one more. So a counter is nothing but a combination of combination logic and sequential logic. Yeah, you can unmute. Yeah, you can talk. Anybody can raise any doubt anytime.
Sir.
Yeah.
Sir, if both the inputs are same for combinational logic and sequential logic, then how for the first bit 0002 001, how it is changing, sir?
Well, that you have to draw the combination logic. That's why I have drawn here. See, I have drawn a combination logic. When there is an input is 000, the output is 001. Whenever there is a cross comes, it goes out.
We are assuming initially.
Yeah. Well, how it is assuming, that is another logic. We have to use a reset.
Okay.
Use a reset to do it. Then I have to draw a bigger one. I don't want to do have a very big one. I want to give you only an idea. Okay, don't.
We are assuming, sir.
Yeah.
Only we are assuming, right? For 000 for 0.
No, we don't assume. There is a logic, reset logic is there. Here what happened with the outputs? In between, there is a reset comes. When reset become 1, whatever may be this one, the output becomes 0. One more combination logic is there. Okay. So that when this will go here and this will get connected here. The reset will make everything is a 0. So we have a much more complicated diagram. I don't want to get it. So what I'm trying to tell you is this. See, this is what the idea. The idea is this. We have a combination logic. We have a sequential logic. This guy gives an input here, 8. This is 8. And this is 8. This 8 goes here. So there is a signal here called C. When this is controlled, whenever there's the C comes rising edge, this guy will increment. This guy not increment, he will pass here to here. But this guy is the one who is incrementing. The combination of these two together is called counter. This may be this both sequential logic, shift register and counter maybe confuse you. If somebody wanted to know in depth, let me tell me. I can able to make few videos and send it to you. If somebody want to have an in depth of this, how they do that, and they are if you have a time to go through that, you can go through that. If you want anybody want to have an in depth, I can make a videos and share it on the people. But I wish don't get in too much. See, if you have a your journey is different somewhere. If you like to take rest everywhere, then your journey is here. You have to go to the journey here. When I was doing in 1980, my stop was here last end. So I was spending time everywhere. But today, after this, you have gone microprocessor, microcontroller, and controllers, SOC, and you have come here, highway. So you cannot stop here. You go very high speed and come here and take rest. Here you spend all your time. Your 99% of time you spend on the embedded system programming, I'm happy. But of course, as I told you that I lived in the world in 1980s. So I know everything, all this digital everything. So if anybody wanted to interested, send me a message in WhatsApp. I'll be able to make a video. If more people have requested, I can make a video and give it to you. Understand?
Sir?
Yeah.
Sir, previous topic you have explained in the board for parallel input, right?
Correct.
Sir, for serial input, same input will be carry forwarded to the next D flip-flop, right, sir? For serial.
No, wait. You are right. I'll explain to you that problem. I'll explain to you right now. Right now, I'll explain to you one thing. You see here, I have a block, one D flip-flop. I add only one or two. I add only two. 2 D flip-flop. Please understand, don't forget this. D will have a one input called D, one input called Q. D and Q, that's all. And there is an input called C. You should never forget this. Now, I have two inputs here. One is parallel input. Understand? And this guy is having only one input. Fine. Because there's no serial input. It's the first one, MSB. But whereas this guy had two inputs. Let's say this is called parallel input. This is called serial input. D1, Q1. Now, if you connect like this, that is called shift register. Q1 goes to the D1, D0, and this goes to Q0. This is called, if you connect like this, it is called serial shift. Whenever C comes, the D goes to Q. So it goes like this. But when I connect like this, that time the P goes to Q0. This is called parallel load. This is called parallel load. This is called serial shift. Now what we are doing here is we are making a logic. We are making a logic here which has two inputs, parallel as well as Q1. And I have a control here. This is called SP, serial shift or parallel. Now I say that when SP is 0, this will be connected. When SP is 1, this will be connected. How do I do that? I have an AND gate. I have an AND gate. Both the outputs are connected to OR gate. Now, a AND gate can be enabled by another input. If this input is 0, this AND gate is disabled because this output is 0. This don't have any control over this wire. If you make it 1, the input goes to output. Now what I have done here, this logic, if you draw here, this logic, we have two AND gates and we have OR gate. Now I have an input called P0. I have an input called Q0. If you write a program, X is equal to 10, that time 10 should come here. This is called parallel load. Now you say Y is equal to X, right shift by 1. This is called shift. When I do the second operation, now I have an input called SP. When SP is 0, when SP is 0, there's an inverter. So now P0 goes here. When here I connect this, when SP is 1, then it becomes Q0. So now you can erase this logic. Normally you don't try to get in. When you know that you can design a logic, don't get into the block too much. This block has 3 inputs, P0, Q1, and the D0. And this is SP. When SP is 0, P0 goes. When SP is 1, Q1 goes. You need to design this logic. This is what you're supposed to have learned in colleges as an application of combinational logic. Now I'm telling you that what is the use of combinational logic? What is the use of sequential logic? That's it.
Now clear, sir. Thank you, sir.
Yeah,
now exactly.
That's it.
Clear. Thank you.
Now you go. If you wanted to go in depth on the thing, read the book of Digital Computer Fundamentals by Malvino. In my life, I read only one book from first page to last page. There's only one book I've read in my life. If you wanted to understand thoroughly digital, read from the first page to last page of this book. digital computer. Read like a story. This is almost a story book. It costs about 500 rupees on Amazon. It's a, if you want, I have the PDF copy. I can share with you. If you really wanted to let me know that, I share the PDF copy. So understand this. So we have seen 3 of the logic, but the counter and shift register may not be directly applicable to you, but you will know that why it is. But the most important thing is your 8-bit latch. That means I give a data 8-bit, I get output 8, and I have a control signal C. Now C is derived by my address 16, and data is coming from my microprocessor. These 2 are coming from my microprocessor. Microprocessor is giving address 16 and data 8. Now I'm assuming, but it could be 32 or 64 or whatever it is. We are discussing about only small one case. Now, if you write a program, char star x, x is equal to 0x, 1, 2, 3, 4, and star x is equal to 0x, 15. Then this guy will give you 1, 2, 3, 4. This will become 15. Then 1, 2, 3, 4 will come here. Sorry, address. This guy name also 1, 2, 3, 4. This become 1. And this is 15. The 15 will go here. This is actually output. Please understand this. Maybe my next session, this will be very clear. Another application. How we are going to use this to build a RAM. How we are going to build a RAM. Okay. Let's take a small break for about 5 minutes. Yeah, somebody has asked a question. Yeah. This is the only small pieces, not a big one. I'm not trying to put you so much things into your brain. I have concisely taken very limited things. See, I'm not, see what they teach you in the 1 semester, digital electronics. I'm teaching you in 8 sessions. What they teach you the microprocessor 1 session, I'm teaching you on 8 sessions. What they're teaching you on 1 semester for microcontroller, I'm trying to teach you on 8 sessions. It's enough. You'll be able to thoroughly understand them. They are not something great. The problem is once you get a thorough picture of these things, once you get a full picture of this, then you will be really surprised. Once you get a full picture, then you will thoroughly understand that, hey, these things are so simple. That's why follow from beginning to end. Okay. Next week, after next week, we are going to discuss about electrical. Once we discuss about electrical and electronics, that's it. You will thoroughly understand the whole thing. Our flow become very easy for you. That is, it goes like this. Let me draw the flow once again. Then you will understand that how easy it is. See, electrical. Then to move to electronics. You should understand how electrical becomes electronics. Then electronics, we have digital electronics. Then microprocessor. Then microcontroller. Then embedded system programming. See, 1 session, 2, 3, 4, 5, 6. But when you till this is fine. But for embedded system programming, you require C language and C programming. That's all. Totally 7 and 8. That is what our full force is organized as 8 sessions. 8 into 8, 64 hours. Don't tell me that you don't get 64 hours in your life. You just watch the class, attend the class and watch the videos. 64 hours is how many days? Think of it. If you spend 8 hours per day, 64 hours is 8 days. That's it. That's it. The sequence has to be followed. The sequence has to be followed very nicely. Even without the sequence, you can understand, but you have a questions. How come the transistor become a switch? We explain here. Then we explain here how this become electronics. What is that? How the transistor works, all those things. So please understand, we concisely put everything as a 64 hours, but you have to practice. You have to practice. You have to practice. How many hours you practice per day? How many hours you slog to practice? That will make you to the entry into the big companies. But nothing more than that. This is what the whole thing, whether you study in Stanford, whether you study in this one, IIT, or whether you study in third tier college, this is what the total thing is. It doesn't matter. So let me stop this class recording.